In this lecture, we are going to continue our discussion on implication operator, and in this particular lecture, we will talk about the different ways to represent the conditional statements. Now, here are the different ways we would be able to represent the conditional statements. We are already aware about if P then Q. This representation is the representation of conditional statement. If P then Q. Meaning is quite simple. When P is true, then Q has to be true, right? It is not the case that when P is true, that Q can be false, because in that case the conditional statement becomes false, right? The another way to represent a conditional statement would be P implies Q. P implies Q is equivalent to if P then Q, and we are already aware of that fact as well. Q when P. Obviously, when P is true, then Q definitely needs to be true. This is what this particular statement means. Q whenever P. This is also the same as Q when P. Q follows from P. Simply, Q follows from P because when P is true, then Q has to be true. Therefore, finally we can conclude that these are all the multiple ways to represent the conditional statements. Now, here are another ways to represent the conditional statements. P only if Q is the way we would be able to represent the conditional statement. Now let me tell you one important point. These are all very important conditional statements and very confusing at the same time. If we want to understand these different representations, they are not very much difficult to understand, but these are quite difficult to understand. Therefore, our focus would be to understand these different representations one by one. Okay? P only if Q is equivalent to if P then Q. We are going to prove this. P only if Q is equivalent to if P then Q. Now it is quite confusing because here if is in front of Q and here if is in front of P. But still I am saying that they both are equivalent. Why? We will prove this very soon. Q is necessary for P. P is sufficient for Q. Q unless not P. These are all the different ways to represent the same idea, that is if P then Q. Okay? So now let's discuss them one by one. Our first conditional statement representation is P only if Q. How if P then Q and P only if Q can be same? This is the question that we need to answer. How if P then Q and P only if Q can be same? Let's try consider one example. I will stay at home only if I am sick. Okay? I will stay at home only if I am sick. Let P is equals to I will stay at home and let Q is equals to I am sick. Okay? So as we can clearly see, this statement is of the form P only if Q. Isn't that so? Here P is I will stay at home and Q is I am sick. Now, according to the above statement, becoming sick is the necessary condition that will make you stay at home. Here I am making a promise that if I will stay at home, then the only reason would be that I am sick. That's why I am staying at home. This will be the only reason that will make me stay at home. So becoming sick is the necessary condition that will make you stay at home. We can say this statement in other words as well, like if you are not sick, then you cannot stay at home at any cost. Isn't that so? Right. From this particular statement, we can conclude that if you are not sick, then you cannot stay at home in order to make this compound proposition true. Right? Therefore, the only way to falsify this statement would be when Q is false and P is true. When we make this particular proposition false, that is, I am not sick, and when we make this particular proposition true, that I will stay at home, then only we would be able to make this compound proposition false. As you already said that I will stay at home only if I am sick. Now, if you say that I am not sick, but I am still staying at home, then this compound proposition becomes false. Isn't that so? That is why In order to make this particular compound proposition false, we have to make Q false and P true. Okay? Now we are going to prove that if P then Q and P only if Q both are same. Proof idea is quite simple. Truth value of P and Q must be same in order to falsify the statement. What we are going to do is that, as we know, in order to falsify this statement, we are taking Q false and P true. The same truth value we will use to falsify the statement of the form if P then Q as well. We will represent the statement in the form of if P then Q. If we would be able to falsify the statement of the form of if P then Q with the same truth values of P and Q that we use to falsify the statement of this form, then we would be able to prove that both are same. Now let's consider the proof. As we know, this is the representation of P only if Q. If we want to represent this same statement of the form if P then Q, then how it looks like? If I will stay at home, then I'm sick. As we know, P is I will stay at home and Q is I'm sick, then if P then Q looks like if I will stay at home, then I am sick, right? Now think about it logically. Here I'm saying I will stay at home only if I'm sick, right? Here I'm saying if I will stay at home, then I'm sick. As the only reason for staying at home is that when I'm sick. Here also I'm saying that if I will stay at home, then definitely I'm sick. That is why I'm staying at home. So they both sounds equal, isn't that so? As we know, the only way to falsify this particular statement is by making P true and Q false, isn't that so? We are already well familiar with the constructs like if P then Q. We would be able to falsify this statement by making P true and Q false. Therefore, P only if Q is equivalent to if P then Q. Why? Because here also, if you remember, we falsify this particular statement by taking Q false and P true, right? Here also I am taking the same truth values of P and Q and falsify the statement. By taking P true and Q false, we would be able to falsify this statement as well and this statement as well. Therefore, P only if Q is equivalent to if P then Q, and it is hence proved. If you are not satisfied with this proof idea, and if you feel like it is not a better way to prove this particular statement, then don't worry. We will use the same proof idea to answer one more important question. And here is the question. Why P only if Q is not equivalent to if Q then P? As we already proved that P only if Q is equivalent to if P then Q. Now let's try to understand why P only if Q is not equivalent to if Q then P. Here also I will use the same proof idea that I used in the previous case when I proved that P only if Q is equivalent to if P then Q. Let's take the same example. I will stay at home only if I am sick. This particular proposition is of the form P only if Q. Okay. Now here P is I will stay at home and Q is I am sick. Now let's dive into the proof. P only if Q is false when P is true and Q is false, right? When P is true and Q is false, then P only if Q is false. Isn't that so? Let's try to represent this statement of the form if Q then P. Now how is it looks like? If I'm sick, then I will stay at home, right? If you remember in the previous case, I represented this statement of the form if P then Q. There I had written if I will stay at home, then I am sick. Here I am writing if I am sick, then I will stay at home, right? Because I need to represent this particular statement of the form if Q then P and not if P then Q. So it looks like if I am sick, then I will stay at home. Are they both equal? Let's try to prove that. As we know, we would be able to falsify the statement of the form P only if Q by taking P true and Q false. Here also we will take the same truth values of P and Q and try to make this compound proposition false? Let's take P true. We know that P is I will stay at home. So let's make this particular proposition true. And let's make this particular proposition false, right? Now, we know that false implies true is true. Isn't that so? We already know that when this proposition is false and this proposition is true, then the whole compound proposition becomes true. Let me change this to Q implies P. And this to P and this to Q. Here in this particular statement we are saying Q implies P. We know that here Q is false, here Q is false and P is true. Isn't that so? When Q is false and when P is true, Q implies P would be true. But we know that when we take the P value true and Q value false, then P only if Q is actually false. And this also needs to be false. But unfortunately, this is true. Obviously, in this particular statement, this is not a strict condition. Here in this particular statement, I am sick is the necessary condition. If this is not satisfied, then this is not satisfied, right? But here this is not a necessary condition. Here I am simply saying if I am sick, then I will stay at home. Now suppose if you are not sick, then you may stay at home, then you may not stay at home. It depends on some other factors. But here I am saying I will stay at home only if I am sick. So if I am not sick, then I should not stay at home. But here there is no restriction at all. Here if you are not sick, then you can stay at home. You cannot stay at home. In both the cases, the compound proposition is still true, right? But here, when Q is false, then P has to be false. Then only we would be able to make this compound proposition true. Let me read this statement. As when P is true and Q is false, P only if Q is false. But with the same truth values of P and Q, if Q then P is true, right? Therefore, P only if Q is not equivalent to if Q then P. Hence, it is proved that P only if Q is not equivalent to if Q then P. Now please also remember one important point. If you remember in the previous example when we talk about P only if Q, when we are saying from the context of Q, we said that when Q is false, then P has to be false. We didn't say anything about when Q is true, then P has to be true. Why is it like that? Let's see the truth table. When Q is false, then P has to be false. Isn't that so? If it is not the case, then the whole compound proposition becomes false, right? But why we cannot say when Q is true, then P has to be true? Why we cannot say when I am sick, then I have to stay at home? I will never say that if I am sick, then I have to stay at home. I can only say that if I am not sick, then I should not stay at home. Why is it like that way? Because according to the truth table, when Q is true, P can be true or P can be false. Both are correct because both will make the compound proposition true. Isn't that so? But here there is only one way we would be able to make the compound proposition true. When Q is false, P has to be false. But when Q is true, it is not necessary that P has to be true. P can be true, P can be false. We can still make the compound proposition true. Please remember this point. Therefore, when we are talking from the perspective of Q, then we can only say that when Q is false, P has to be false. And if you remember that when we talk from the perspective of P, then we said that when P is true, then Q has to be true. Why we cannot say that when P is false, then Q has to be false? Let's see the truth table again. When P is true, then Q has to be true. Then only we would be able to make the compound proposition true, because in the other case it will be false. But why we cannot say that when P is false, then Q has to be false? Because when P is false, then Q can be true or Q can be false. The whole compound proposition is still true. Therefore, we cannot guarantee that when P is false, then Q has to be false. Therefore, the final conclusion is that when we are talking from the perspective of P, then we can only guarantee that when P is true, then Q is definitely true. And when we are talking from the perspective of Q, then we can only guarantee that when Q is false, then P is definitely false.